True health is an active state of optimal physical, mental, and social efficiency. It is a high-level performance that encompasses much more than the mere absence of sickness. Maintaining that equilibrium is a constant, invisible struggle. Our systems must continuously react to a barrage of environmental and societal stressors that surround us every day. Biological understanding requires viewing the body as a delicate, interconnected network, a system that works tirelessly to maintain its balance in a hostile world. When that balance fails, we experience a state of disturbed ease, a disease. This is a physical disruption where the normal functions or appearances of the body's organ systems change for the worse. The timeline of these disruptions tell us a lot about the threat. Acute diseases are fast, temporary storms like a common cold. They pass in a few days and leave no lasting damage to our general health. Chronic diseases offer a stark contrast.
Conditions like tuberculosis or elephantiasis act as slow, long-term erosions. They can last a lifetime, causing severe structural deterioration to the body over years. The duration of a system's malfunction provides the first clue to the severity of the threat. When tissues are compromised, the body sets off warning alarms. We experience headaches, coughs, or inflammation, symptoms that signal something inside is going wrong. However, a symptom is a subjective feeling. It announces that a breach has occurred, but a headache alone cannot distinguish between simple examination stress and a severe brain infection. To find the actual culprit, physicians look for definitive signs, objective evidence of a specific illness, and conduct laboratory tests to pinpoint the exact disease. Treating only the symptoms is like turning off a fire alarm without putting out the fire. True healing requires identifying the root cause of the disruption. The root causes of disease generally fall into two categories: internal system errors, like genetic abnormalities or high blood pressure, and external breaches. These external attackers are infectious agents, microscopic organisms that invade our bodies, multiply, and spread rapidly through a community. These invaders are biologically diverse. They come from completely different taxonomic groups, meaning a spherical staphylococci bacterium operates entirely differently from a larger single-celled protozoan. The threat spans an enormous scale. It ranges from tiny viruses hijacking our cells, to protozoans, to multicellular parasites like ascaris worms exploiting human hosts. Identifying the exact biological family of the invader is critical. Because these groups have vastly different life processes, a weapon designed to destroy a bacterium cell wall is useless against a virus that lacks one entirely. Because these infectious microbes are communicable, they rely on specific environmental transit routes to move from a sick person to a new host. One common route is airborne. When an infected person coughs, heavier droplets fall to the ground quickly, but smaller droplet nuclei can recirculate indefinitely. This makes overcrowded, poorly ventilated spaces a massive transmission threat. Pathogens exploit other routes as well. Cholera microbes spread through contaminated drinking water, while vector-borne diseases use living intermediaries, like mosquitoes, to completely bypass our skin and inject microbes directly into our bloodstream. Every infection requires a physical train of transit. Mapping these specific routes gives us the power to block the transmission before the pathogen ever reaches a new body. When a pathogen does breach our perimeter, our automated defense kicks in. The immune system triggers inflammation, rapidly recruiting specialized white blood cells to the infected tissue to hunt down and destroy the invading microbes. If the infection multiplies too fast and overwhelms the system, we intervene with targeted biochemical weapons. Antibiotics work by blocking life processes unique to bacteria, such as their ability to build protective cell walls. Viruses hijack our own cellular machinery to survive. Because they have very few distinct biochemical targets of their own, they are unaffected by antibiotics and difficult to destroy without harming our own healthy cells. This limitation led to our most effective preemptive countermeasure, immunization. By deploying a harmless mimic of a pathogen, vaccines trick the immune system into building a permanent, specific memory of the threat. A total medical victory involves pre-programming our internal systems to neutralize threats before the disease can manifest, effectively ending the war before it begins. This brings up a final mystery. If an entire room of people is exposed to a pathogen, why do only some individuals actually fall ill? The answer lies in contributory causes. Even a healthy immune system will fail if the body is already weakened by poor nourishment, genetic vulnerability, or the stress of poverty.
Public hygiene, ensuring safe drinking water, functional waste disposal, and clean environments, acts as the foundational outer shield that keeps these contributing vulnerabilities at bay. Biological health truly relies on social health. Clean, equitable, and harmonious communities remain the most powerful medical interventions we possess.